Hello, welcome to Back to Coding. For better understanding of this video, I highly recommend you to check out the previous video or the complete playlist in the description below. Today we'll be talking about layouts and GUI components. You may have noticed that all layout types have attributes in common. Whichever type of layout you use, you must specify the layout width and height using the Android layout width and Android layout height attributes. This isn't just limited to layouts. The Android layout width and Android layout height are mandatory for all GUI components too. This is because all layouts and GUI components are subclasses of the Android View class. Let's look at this in more detail. You have already seen that GUI components are all types of views. Behind the scenes, they are all subclasses of the Android.View.View class. This means that all of the GUI components you use in your user interface have attributes and behavior in common. They can all be displayed on the screen, for instance, and they can say how tall or wide they should be. Each of the GUI components you use in your user interface take this basic functionality and extend it. It's not just the GUI components that are a type of view. Under the hood, a layout is a special type of view called a view group. All layouts are subclasses of the Android.View.View group class. A view group is a type of view that can contain other views. A view object occupies a rectangular space on the screen. Here are some of the areas we think are the most important. Getting and setting properties. Each view is a Java object behind the scenes, and that means you can get and set its properties in your activity code. As an example, you can retrieve the value selected in a spinner or change the text in a text view. The exact properties and methods you can access depend on the type of view. To help you with this, each view can have an ID associated with it so that you can refer to it in your code. Size and position. You can specify the width and height of views so that Android knows how big they need to be. You can also say whether any padding is needed around the view. Once your view has been displayed, you can retrieve the position of the view and its actual size on the screen. Focus handling. Android handles how the focus moves depending on what the user does. This includes responding to any views that are hidden, removed, or made visible. Event handling and listeners. Each of your views can respond to events. You can also create listeners so that you can react to things happening in the view. As an example, all views can react to getting or losing the focus, and a button can react to being clicked. As a view group is also a type of view, this means that all layouts and GUI components share this common functionality. The layout you define using XML gives you a hierarchical tree of views and view groups. As an example, here's a relative layout containing a button and an editable text field. The relative layout is a view group, and the button and text field are both views. The view group is the view's parent and the views are the view group's children. Behind the scenes, when you build your app, the layout XML is converted to a view group object containing a tree of views. In the example above, the button gets translated to a button object and the text view gets translated to a text view object. Button and text view are both subclasses of view. This is the reason why you can manipulate the views in your layout using Java code. Behind the scenes, all of the views are rendered to Java view objects. That's it for this video. I'll be continuing more on this topic in the next video. Thank you for watching this video. Please do like, share and comment on this video, which really motivates me to make such useful content for you. Also, don't forget to check my other videos which can be helpful to you, and finally, subscribe to my channel.